Start over. I'm Joel Austin, Regional Manager with Esteem Wireless, and we're going to talk about modernizing your network for Ethernet networking. And what we're kind of talking about here is this move from Industry 3.0 to 4.0, device level type communications into a full-blown network. Now, when we're talking about wireless, there's always this question around good or bad frequencies. Which ones are good, which ones are bad for me to use? There isn't good and bad, there's just right and wrong, and that'll depend on a lot of different factors. But moving through those, we've obviously got to make a decision, and more than likely when you're moving to Ethernet, you're moving into a unlicensed broadband type technology that'll let you get a higher level of throughput than you typically could through a licensed frequency, as an example, or a narrowband type solution. And in doing so, we've got pretty much, a few choices here. We can go with the 900, the 2.4, and the 5.8, and we'll talk a little bit about what, some of the advantages and disadvantages of those. Moving through into starting with the 900, because this has for a long time been a very common frequency used in industry. So 900 obviously is license free. It is the most forgiving of all the broadband technologies in out of 2.4, 5.8, and 900. So line of sight isn't as important, but it still matters. It typically has a better range. It doesn't offer Wi-Fi, so there's no security concerns if that is an issue for your application. And then it's there's no open standard for 900. So it has some benefits there for security as well as throughput. Some of the boundaries are typical boundaries for unlicensed frequencies, right? You have to share the air with everybody else in the area who may or may not have a solution on 900. No Wi-Fi means no Wi-Fi. So that might be a problem, and you may want to go with a different direction because you need Wi-Fi access as well. The bandwidth is going to be less than your higher frequencies. So is that enough for your application? And then obviously the topology is going to matter. But a lot of people have moved away from 900 because of its frequency hopping spread spectrum technology that it was based on. But as I mentioned, there's a lot of it out there, but that frequency hopping technology just makes it too slow. It's essentially a bunch of center channels that's hopping around. So you get less than 1 meg, and this typically isn't enough for modern Ethernet applications. And then the encryption was kind of, as we like to say, security through obscurity. First of all, you're on 900. Second of all, you've got this center channel that's moving all over the place. But there really wasn't any meaningful encryption being done, if at all. So now that a lot of people have 900, they're kind of stuck out there with no backward compatibility of any new solutions. Well, at Esteem, we've embedded kind of a different technology, which is based on a Wi-Fi technology called OFDM that has now allowed us to get our 900 up to 72 meg throughput. So this is available on 5, 10, and 20 megahertz channels. It's obviously free. We can mesh this radio, and it uses AES 256 encryption, which is very secure. And then all of our Horizon devices, including the 900, will have multiple modes of operation. Not only do you get one spare for all, but you can dual purpose a single radio. For example, it could be a station, which services the local equipment, as well as a repeater for other areas. Layer 2 bridging, layer 3 routing, and then it has mobile roaming capability as well, which kind of works like cell phone. So to show you a little bit different about this frequency hopping versus OFDM, here you can see those center channels that I was talking about, where these things are just firing off and moving around and hopping around. And it was really designed primarily for noise avoidance. There is an amount of security you get with it, but it's basically noise avoidance, right? And it just sends a packet, moves, sends a packet, moves. OFDM, however, uses a much different technology where it's kind of sending down a tube, if you will. So it allows much more data to be packed into the same size pipe is what it amounts to, without being really a compression algorithm, which is a different thing altogether. So to put this in more tangible terms, if you looked at any individual one of those center channels that you get to fire a packet down or information down, you're looking at a tube, a pipe, a straw that's roughly 5/6 of an inch in diameter. So just shy of an inch around, and you're trying to force water through this, right? The difference between that and our 72 meg OFDM technology would be a 17-foot culvert that you're trying to put water through. As you can see, there's an immense difference there. And then to the final point about this, the final comparator, right here in this little area on your 12 megahertz or 12 kilohertz channel, sorry, you're looking at about 64K max throughput. What does that really mean? Well, at 72 meg, we're roughly 1,000 times more data available, more space available. So you could, in essence, have 1,000 of these 64K narrowband radios sitting beside each other, servicing a unit, or one of these, in essence, is what it boils down to. Now, okay, with all of this technology, how difficult is it to set up, right? So pretty simple. You just go out and discover it, and then you start drawing lines between the units to configure them, and then push the configuration out to the radios. You don't need the radios to do this, and they can, you can just set up a dummy network with dummy radios, and then go in, once you get your radios, identify them in each location, and start configuring both the radios themselves, the pathways, making all your different manipulations. And if you want to change something, you can always go back, click on the link, click on the radio, and make your necessary changes in the screen you see here. We also have monitoring capabilities. So you use the same piece of software in a monitoring function, and you can see here, you can see everything from RSS to throughput and whether or not the channel is active or blocked at the moment. And that will depend on how your mesh is set up, okay? You can also push diagnostics out through Modbus registers, pushing this to your visualization software, to SQL database, whatever you want to do. Now, moving into some of our the round out our product offering here, we're going to talk about 2.4, which is license-free operation. Again, it has a little bit better data rates. Our new MIMO 2.4 gets us up to 300 meg throughput. It can be both access point bridge at Wi-Fi frequencies, which allows you to connect third-party devices, mesh technology, and then it has 11 channels of operation. The boundaries to 2.4, again, are the same as they were for 900. It's license free, so you're sharing the airspace with other people. Line of sight becomes required at this level. You really need to get decent line of sight, and but there's an increased cybersecurity because of the Wi-Fi access, and the range is a bit reduced because of the higher frequency and being less tolerant. You only get about 5 to 7 miles. Okay, but again, the Horizon 2.4 can do all of our industrial mesh. It has multiple modes of operation: layer 2 bridge, layer 3 routed. It has, again, the AES 256 encrypted connections, the Java utility configuration that I just showed you, as well as onboard memory. So you can actually put a memory module in this device and have it, you can download your program to that memory device so that if you swap between units, you can remove an SD card, which is going to be located here behind that screen. You undo the Allen screws, pull the SD card out, put it into the new radio, tell that radio to upload from SD card, and it will not only become the same IP address, but the same MAC ID, so that there's no need for IT to change any of the MAC filtering that they need to do. And this is all hidden behind administrative passwording and things for security. 5.8, moving into 5.8, we're kind of telling the same story here. 300 meg throughput, license free, self-healing, access point and bridge through Wi-Fi, 17 channels of operation, 5 of which are Wi-Fi. And then the boundaries are about the same, except for obviously we're going up in frequency. So now we have absolute line of sight required. We have a higher liability, or as high a liability with the Wi-Fi. And then we kind of lose a little bit of range here, 3 to 5 miles. But again, this might be the right application for you because of some other things that that are going on with 5.8 that you may need. The Horizon 5.8, like the 2.4 and the 900, can both mesh, multiple modes of operation, layer 2 bridge, layer 3 routed, 256 Java based, and the memory module. So throughout the Horizon series, capabilities stay about the same as far as the function of the device. What changes is the technology that it uses based on the frequency that you select. Okay. Now, some of the other capabilities that you can utilize with the Horizon for Ethernet solutions is our twin bridge technology. Okay. So what this allows you to do is, many people are talking about separating the control network traffic from the visualization traffic. Well, we allow you to do this on 2 separate subnets on a single radio, thus reducing your hardware costs, but keeping your data segregated. Okay, so essentially how it would look is this. Here we're setting up our control network. So we have our control going out to all of these locations. Then we need our visualization network, and our visualization is pulling from these locations. So ultimately, what your network would look like is something along the lines of this. You can see here we have the shared paths, dedicated control, dedicated visualization, and they're all sharing the same wireless network. Okay. Moving forward though, now that we've talked about how we're going to set up our control network, how we're going to set up our visualization network, now we may have, let's call them very remote or significantly remote locations, possibly in another state or in a completely different location on the planet. How are we going to access those locations and maybe remote into them? Well, what we would do is use our Edge Access Plus solution over Wi-Fi to gain access. Now, our remote access network extension solution here in the Edge Access is a little different than maybe what some others are doing. Instead of being cloud-based, this creates a VPN tunnel, okay? So there's no cloud repository for data necessarily. It can, it just doesn't have to. It has MQTT on board that it can push. But essentially what this allows you to do is you leverage this for remote access. You can bridge your existing network through the VPN, or you could point-to-point solution this however you need for your application, but it's also completely scalable. So you could start out with 1 and then move to 5, 10, whatever your application needs. It's automated. You do not have to create the VPN and do a bunch of networking. It really does set up easily enough, and we'll talk through that. The device itself has your LTE interface, which has 2 SIM cards available. So you can offer a primary and a backup for yourself or to your customer that can give you 2 different cell network accesses, just in case your primary goes down, you have a backup if that's necessary. Layer 2 bridged, layer 3 routed. Edge to cloud, obviously we talked about that a little bit with the MQTT, and then it can be a point-to-point data flow with again, the AES 256 encryption for security. Okay, so let's talk a little bit about how one would go about leveraging this. So here we have our device. We have a crypto key that basically syncs up with this thing, right? So the two become married together. You place them anywhere you want on the planet. Plug the key into a computer, put the device connected to wherever you want to access to, and they will link up regardless of where they are on the planet in relation to each other. You can also have a single key access multiple devices if this is what your application calls for. Okay. Now, there's also a virtual box solution that we partner with TosiBox with that you can run on VMware that will allow you to assign licenses to people and give them access to these different locations. Okay. So for example, your network could be given access to all of these. Some of these you could assign somebody from a Steam access to one location and the rest to every location. You can limit, mix, match, however you want to do this. Okay. So the algorithm is kind of extensive on how you want to limit. It could be for a day, a month, a week, an hour, one-time use, however you want to offer the license to those in need. So you can also, as I mentioned, push data through MQTT to the cloud. So if you want that cloud repository or cloud backup, or that's where your database information is collected, you can push it to the cloud. You can push it directly across your network to a SQL database. It's totally up to you. And this will work with all AWS, Azure, all the main cloud-based people. I don't know any that it won't. Everybody's pretty much MQTT compliant today. And that somewhat rounds out our modernization. I wanted to check real quick here to see if anybody had any questions. Everybody pretty much good here so far? Okay. Well, just to touch on some things upcoming, here we are with our Modernizing for Ethernet Networking. Our next webinar will be on 5/11 for Modernizing for Reliability, where we will discuss mesh and a number of other things that we do for both reliability and keeping maximum runtime. So any questions, any concerns? Nothing? Okay, well, thank everybody for their time. I appreciate it. If you have any questions that come back around, this is my contact information. I'll be happy to answer any questions for you. If you can't get a hold of me, or for some reason you want to just call in directly to the office, this is, oh, excuse me here, let me see. Not sure why I lost my pointer, but I did. Right here is the office phone number. This is my cell, and obviously this is my email. So thanks again. Appreciate everybody's time, and have a great day.